Yep.
You doing okay?
So far. All right, hi, it's calculus. So I want to go over some of the questions that were asked of me, and that would be 1A, and 2, every question I gave you, which is B, D, and E. So I want to go over those, and then I will finish off this section. 1A says my limit as x approaches negative infinity for e to the x. So basically, if I put a very large negative number in there, what would my answer be approaching? So if I put like e to the negative 1,000 or e to the negative 10,000, the bigger I make that negative number, the closer I get to 0. And that's 1A. 2 wants us to differentiate. So basically, find the derivative. So y is equal to 4 over e to the x. Now, if it were me, first off, Wicket, stop spinning. If you're going to go around, at least go around right. If it were me, I would rewrite this as 4e to the negative x. So when I bring it up and it's no longer a denominator, now it is negative. So if I'm going to do the derivative, just think about it this way. If I was going to do the derivative of 4x squared, right, I would do, I'd bring it down and da-da-da-da-da. So I guess technically, let me do this technically. Technically, the way you would do this is 4 is your f, e to the negative x is your g. So technically, you should do the product rule with that, which is g f prime plus f g prime. So if I do that, g is e to the negative x, but the derivative of 4 is 0. So when I multiply those two, that's just going to be gone anyway, plus f, which is 4. But now I have to do the derivative of g. To do the derivative of g, first I do the derivative of e, which is just e, and I leave that alone. And then I do the derivative of negative x. The derivative of negative x would be negative 1, right? If you have negative x to the first, you bring the 1 down, it's negative 1, you decrease that by 1, and that's 0. So to clean this up, that would just be gone. 4 times negative 1 would be negative 4 e to the negative x. And that's how I would do 2b. 2d says, oh, I did 2a. I didn't do 2b. I did 2a. That's how I do 2a, if that helps. Let's do 2b instead. X to the 6, e to the x. Let's do this one instead. If I'm doing this one, so now you know how to do a, even though I didn't ask it. Again, I would do the product rule with this. So g f prime plus f g prime. So again, the x to the 6 would be f, the e to the x would be g. So g is e to the x, f prime is 6x to the 5th. Again, just regular old derivative. Plus f is x to the 6th, and then I have to do the derivative of this. Well, the derivative of e is just e, and then the derivative of x is just 1. So, again, to clean this up, I have 6x to the 5th e to the x. I just like the e on the end, no reason. Plus x to the 6th e to the x. Now, I have not looked at the back of the book. I probably should. But I have not looked at the back of the book to see what they list as their answer to be, yes, they do. So yesterday in the video, I said I would take, a lot of professors are going to ask you to take out a common factor, but they didn't in the example. And again, this is when they're not consistent, and I don't like that. Really, if I look at this, I have at least an x to the fifth in both of them. So x to the fifth is common to both, and an e to the x is common to both. So if I take x to the fifth and e to the x out, I have 6 left. And if I take x to the fifth and e to the x out, I just have 1x left. So all they did was take out a common factor. So if you're looking at the back of the book and you had this, but they have this, the only thing they did was go one step further and take out a common factor. Like I said, if you were going to go forward in this and take it at university, and I don't know whether you will or not, but if you do, I would say probably 95% of professors are going to be looking for this. If you go here, they're not going to give you full marks. All right? D, I'll try and do the right question this time. D says x squared e to the negative x. So again, here is f, here's g. So if I'm going to do the derivative, g, f prime plus f, now g prime, the derivative of e is e, the derivative of negative x is -1. So I have 2x e to the negative x minus x squared e to the negative x. Now again, potentially you left it here. If you're taking out a common factor, there's at least an x in both of them, and there's an e to the negative x in both of them. If I take an x and an e to the x out, all I have left is 2. If I take an x and an e to the x out, all I have left is x. So I would have that. And again, I'm just going to double check at the back of the book and see what they say. D. Yep, that's what they have. All right, so I agree with the back of the book, which is good. E. E, there were quite a few questions about. I've not done it yet, so if I screw it up the first time, you can let me know. E to the x over x. So I would rewrite that as e to the x, x to the -1. And again, I would think about g f prime plus f g prime. This being f, this being g. So my derivative is going to be g, x to the -1, f prime. The derivative of e is e, the derivative of x is 1, plus f. F is e to the x. G prime would be negative x to the -2. Now this is multiplying, that is not a minus, right? Because that negative's on there. So let me just clean this up. X to the -1, e to the x. I would do minus x squared e to the x, or sorry, x to the -2 e to the x. Now, at the back of the book, what they have is something different than that, okay? What they have is something different than that. Let me see if I can explain what they did. So this would be e to the x over x minus e to the x over x squared. Okay, so common to both would be e to the x over x. If I take that out, if I take that out of here, I just have 1. And if I take that out of here, I have 1 over x. And what they have is, x minus 1. Yeah, and so what they've done is they didn't like the x down here, so they did some finding common denominators, and they did all kinds of work. I'm actually fine if you have it here. I'm even okay. Another thought that you could have would be, since I'm subtracting fractions, is to get a common denominator of x squared, which means I'd have to multiply the bottom by x, so I'd have to multiply, so I would have x e to the x minus e to the x all over x squared. That could be something that you do as well. So that could be a possibility. So yeah, there's different choices there. If you got it here, that would be good to me. I would be happy with that. If you put it here, I would be happy with that. If you went further than that, and so what they would do is they would multiply both sides by x here. So it would end up being x minus 1 in here. That's all they did in the back of the book. They said, we don't want to end up with a fraction, so I need a common denominator inside here. So I'm going to multiply this side by x. So I'm going to multiply this side by x, because we're going to make it like x over x. So this would cancel, and they end up with x minus 1. That's all they really did. They didn't do anything super fancy. So they have e to the x over x times x minus 1. But if you're not okay with that, then don't do that. I'm all right with that. All right, so here, I'm happy. Here, I'm happy. Here, I'm happy. Here, I'm happy. All right, I'm not going to be super fussy. I'm not going to be super fussy. I'm more concerned with, can you actually do the derivative? That's more concerning to me. Okay? All right. So I want to continue this section. I want to finish this section off. I'm actually only going to do 2 more examples. I'm going to do example 4 and only bits and pieces of it. And I'm going to do example 5. Okay, I'm going to do example 4 and I'm going to do example 5. There is an example 6, but I'm not going to bother with it. I'm not going to bother with it. I'm not going to ask anything like it, so it's fine. So example number 4 gives us y is equal to x e to the x, and it wants us to graph this. This goes back to what you just finished doing on your test, finding local maximums, local minimums, finding any limits, finding any intercepts. All of that comes into play. All right, so let's talk intercepts first. If I make my x 0, then I would have 0 times e to the 0. Well, e to the 0 would be 1, but times 0 would be 0. So I already know I have a point at 0 and 0. I already know that. If I make my y 0, then I have x is e to the x. Now, one thing I said to you was, if it's easy to find the intercepts, find them. This is not going to be as easy as all that. I mean, the best you could do is I could divide this side by e to the x so they cancel, and I would divide this side by e to the x, but that still gives me that x is 0. So if y is 0, x is 0, so it's fine, okay? So really, that's it for intercepts. There just aren't any. But now I need to talk about maximums and minimums. So if I'm going to talk about maximum and minimums, I need to find the derivative. If I'm going to find the derivative of this, I have to do the product rule, just like I just finished doing in the homework. So here's f, here's g. So g f prime plus f g prime. So derivative of e is e, derivative of x is 1. So I end up with e to the x plus xe to the x. So common to both would be e to the x, and that would leave me with 1 plus x. So I'm going to make that equal to 0. So either e to the x is equal to 0, or 1 plus x is equal to 0. This one's easy. X would equal -1. This one's not so easy. What exponent can I put on something to get 0? The answer is there's nothing. There is no x value that will give me an answer of 0. If I put 0 as my exponent, e to the 0 is 1, not 0. If I put a negative number in as my x, it's going to give me an answer close to 0, but it's never actually going to get to 0. So the only test place I have is -1. So I need a calculator. So I'm going to check before -1. So let's say -2, and I'm going to put it back into, let's say here. Doesn't matter, you can put it into anywhere. So if I do -2, 1 plus -2, that's -1. And e to the -2, so I have e to the -2 times -1. So if I put that in my calculator, where is my e button? I always lose that thing. There it is. E to the -2 times -1 gives me a negative answer. That means the graph is decreasing before -1. After -1, well, I'll pick 0. If I do 0, I have e to the 0, and 1 plus 0 would be 1. Well, e to the 0 is 1. 1 times 1 is 1. It is positive, so it is increasing. So that means I have a minimum at -1. So let's find out what that is. I'm going to put that back into here. I'm going to do e to the -1. Lost my e button again. I lose it all the time. E to the -1. And then I'm going to multiply it by -1. And that's going to give me -0.36. So -1 is -0.36. So it's here. All right. Now I need to figure out points of inflection. Okay, I need to figure out points of inflection. So I need to do the second derivative. Oh, that's going to suck. Okay, so I'm going to do the second derivative. So I'm just going to erase right to here. So here is this. Here's where it gets yucky, because to do the second derivative, first I take the derivative of e to the x, which is just e to the x. The derivative of x is just 1, so it's e to the x. Plus, but now I have to take the derivative of this, where I'm multiplying two things together. So with this, I'm actually going to have to do the product rule, because this is f, this is g. So g f prime plus f g prime. Okay, so this is g f prime plus f g prime. That's what that is. All right, so if I put this all together, I have e to the x plus e to the x plus x e to the x. So again, I could add those together. I have 2e to the x's plus x e to the x. I could go, hey, I've got a common factor of e to the x, and that would leave me with 2 plus x. I'm going to make that equal to 0. So now either e to the x is equal to 0 or 2 plus x is equal to 0. Well, we already established in the last one that's not possible. So x would equal -2. So I'm going to erase this again so that I have some space. So at -2, that's my test. Oh shoot, I needed my question. It was e to the x, 2 plus x. That's what it was. So that was my second derivative. I erased it and almost forgot it. All right, so it was that. So if I pick a number less than -2, say -3, then I have e to the -3, and 2 plus -3 would be -1. And if I put that in my calculator, I'm going to end up with a negative number, so it will be concave down. If I put in a number bigger than -2, say 0, then I'm going to have e to the 0, and 2 plus 0 would be 2. So I'd have 1 times 2, which is a positive, so I would have concave up. So I have a point of inflection when x is -2. So I need to find my y, so I'm going to put that into here. So I'm going to do e to the -2 times -2, and that gives me -0.06. Ooh, let's make this, let's make down here -1. I need a bigger scale so that I can see a little bit better. So -0.36 would be like -0.4. So if there's -0.4, so let's say there, okay? -1 and -0.4. -2 and -0.06. So it is actually really close. So that's my point of inflection. Now, we also know about limits. And we know that when we have an e to the x, the limit as x approaches -infinity is 0. We've talked about that. We know that the limit as x approaches -infinity is 0. So basically, there's like a horizontal asymptote there. But remember, horizontal asymptotes are weird. It is only at the extreme ends that the graph can't cross. In the middle, it can. So if I'm going to graph this, this is a minimum. And this is a point of inflection. Before this, it's concave down. After this, it's concave up. So here's my concave up, right? Concave up, and here is my concave down. It's not very concave down, right? It's not very concave down, but it is going to curve slightly that way, but it's never going to cross there. So that is what my graph would look like. So not the most fun question in the world, but there it is. All right, one more example. One more example. And then I'm done talking for today. Okay. Example number 5 on page 456 is much, much quicker. And it says, find an equation of the tangent. When we are going to find an equation of the tangent, that means we're going to do y minus y1 equals slope times x minus x1. We know we're going to have to do that because they don't want the slope of the tangent. That would be the derivative. They want the equation of the tangent. So find an equation of the tangent for the graph y is equal to e to the negative 2x at the point x is equal to 0.5. So if you were to graph e to the negative 2x, it would actually go down. It would actually kind of go in this direction. So if this is where my x was 0.5, if we drew a tangent line there, that's not a very good tangent line. If we do a tangent line there, what they're asking is what would the equation of that tangent line be, okay? So I already know that my x1 is 0.5 because they gave that to me. Now I need a y1. So if I need a y1, I'm going to do y is equal to e to the negative 2 times 0.5. So y is equal to e to the negative 1. Now can I tell you that they do not bother to turn that into a decimal. You could put e to the negative 1 in your calculator and get a decimal, but it's going to be really, really long, which means if you do that, you're going to have to round it off and it's not going to be as accurate. So they actually just leave it, y is equal to e to the negative 1. It's just easier, okay? Now we need the slope. I don't know why I put equals, minus. Now we need the slope. The slope means we need the derivative. So the derivative of e is e, and the derivative of negative 2x is negative 2. So the derivative is negative 2e to the negative 2x, which means that is the slope. Now, there's an x in there, and I know that x is 0.5. So I can do negative 2e to the negative 2 times 0.5, which means this is negative 2e to the negative 1. That is my slope. And again, they do not bother to expound that out and turn that into a decimal. They just do 2e to the negative 1. So now we just need to do some cleanup over here. Y minus e to the negative 1 is equal to, if I multiply these, this is negative 2x e to the negative 1. They actually do it the other way. They do 2e to the negative 1x. I don't know why I like my e's at the end. I don't know. And then I do negative 2e to the negative 1 times negative 0.5. Well, negative 2 times negative 0.5 would be positive 1e to the negative 1. So if I move this over here now, I have y is equal to negative 2x e to the negative 1 plus e to the negative 1. And when I move this one over here, there's another plus e to the negative 1. So negative 2x e to the negative 1. E to the negative 1 plus e to the negative 1 would be 2e to the negative 1. And then I could potentially take out negative 2e to the negative 1 as a common factor and end up with x plus 1. I could do that. All right. They have x minus 1. Oh, they didn't take out the negative 2. They took out positive 2. I took out negative. It's fine. So that, as they say, is that. Oh no, I took out a negative 2, so that should be negative 1. Watch my signs. If I take out a negative 2, then that's positive, but if I take a negative 2 out of here, then it has to be a minus 1. If you wanted to, you could change that into a decimal. You could go 2 times e to the negative 1, and then you could expand it out. But this is just as simple, and you don't have to do any work in your calculator. All right, so that's it for today. That's all I'm going to do. It's probably more than enough. And I'm going to give you a few to try. All right, and we'll see you tomorrow.